CNC system is the abbreviation of Computerized Numerical Control System, which is a special computer system equipped with interface circuit and servo drive device. It realizes the motion control of one or more mechanical equipment by using digital instructions composed of numbers, words, and symbols. Since its establishment in 1993, KND has developed hundreds of CNC systems, which are widely used in various metal cutting and processing fields. At present, the company's F-platform CNC system has grown into the backbone of domestic CNC systems. This video mainly explains KND CNC system product classification, software and hardware information, and interface definition of KND's F-platform CNC system. KND CNC system product classification. K2000 represents product series, such as K2000, K1000, etc. T is the machine tool category, T lathe type. M milling machines, G grinding machines. X is the multi-axis identification. F is the platform, L, F platform. 3 is the structure type, 3-10.4 inches or horizontal. 4 inches vertical, 15 inches. I is the bus function identification. A is the key type, the MDL crystal key. D MDL membrane key. Plus is the marketing series number. Product series. The KND product series is mainly divided into machining center, milling machine category, turning milling compound lathe category, and specialized machinery customization for a grinding machine, gear, as shown in the picture. After the system is turned on, press DGN system, it will enter system page, or press and hold the DGN key, and the system will pop up the following navigation dialog box. According to the dialog box, find the system and press the corresponding number key 6. The system will automatically jump to the system page. On this page we can see the current system's product information, boot version, CNC software version, PLC version, glib version, FPGA, hardware information, MDI keyboard, machine panel, and language pack information, and other software and hardware related information. Press the soft key SV info. On this page we can see the servo motor model, encoder type, encoder resolution, driver type, drive software version, and work status, and other information. There are multiple interfaces on the rear interface board of the system for connecting various external devices. The following mainly explains the main connection objects and interface definitions of each interface. External connection diagram. XS01 power socket, used to connect the switching power supply to power the system. The pin definition of the power socket is shown in the figure. XS9 for servo bus interface, using DB type 9-hole socket, used to connect all bus devices, such as servo drives of each axis, and bus type remote I/O modules, etc. The last connected bus type device needs to be installed with a terminal resistor. The servo bus interface pin definition is shown in the figure. XS81 additional panel interface, using DB type 15-pin socket, used to connect the machine tool additional operators panel. The additional panel interface is shown in the figure. Signals explanation. Signal connection diagram. XS80 external MPG interface, using DB type 15-pin socket, used to connect external handwheel. The external MPG interface is shown in the figure. Signal description. XS6 spindle interface, using DB type 15-hole socket, used to connect non-bus spindle servo drive or VFED. The pin definition of the spindle interface is shown in the figure. Signal description. XS60 spindle encoder interface, using DB type 15-hole socket, used to connect the spindle position encoder. The pin definition of the spindle encoder interface is shown in the figure. Wiring diagram. XS91 Machine Operators Panel Interface. DB Type 9-hole socket, used for machine panel or NC keyboard board communication. The pin definition of the spindle encoder interface is shown in the figure. RS for 85Ka or B signal, used for machine operators panel or NC keyboard communication, plus 20 for V pin, to power the machine operators panel or the NC keyboard board of the split type system. Machine operators operation panel layout. Socket description. XS90 RS to 32 or 485 interface, using DB Type 9-hole socket, can communicate with PC or connect and control external devices through this interface. Pin definition of RS to 3 to 485 interface is shown in the figure. Signal description. XS7 for DIDO interface, using DB Type 26-3-hole socket, local PLC input or output signal interface. Pin definition of DIDO interface is shown in the figure. XS71 input interface, using DB Type 25-pin socket, local PLC input signal interface. The input interface pin definition is shown in the figure. XS70 output interface, using DB Type 25-hole socket, local PLC output signal interface. The output interface pin definition is shown in the figure. XS9 to Ethernet interface, using RJ45 socket, used to connect the CNC system and the PC, and can communicate with one or more computers and CNC systems. RJ45 socket pin definition is shown in the figure. The Ethernet connection cable adopts a crossover interconnection method. One end of the cable is connected according to T568A, and the other end is connected according to T568B. The cable connection diagram is shown in the figure. JP jumper switch. The JP can be used to set the spindle VP voltage, spindle PC signal voltage, pull-up resistors for T01 to T08, and ESP3 point for specific setting methods. See the following figure and table. Precautions. When designing CNC systems, anti-interference measures such as shielding space electromagnetic radiation, absorbing impact current, and filtering power supply noise have been adopted, which can prevent the influence of external interference sources on CNC itself to a certain extent. In order to ensure the stable work of CNC, it is necessary to take the following measures when installing and connecting CNC. 1. CNC should be kept away from interference-generating equipment. 2. To power the CNC through an isolation transformer, the machine tool where the CNC is installed must be grounded, and the CNC and drive must be connected to independent ground wires from the grounding point. 3. Interference suppression. Connect an RC circuit in parallel at both ends of the AC coil. The RC circuit should be installed as close to the inductive load as possible. Connect a freewheeling diode in reverse parallel at both ends of the DC coil, and connect a surge absorber in parallel at the winding end of the AC motor. 4. The lead-out cable of CNC shall be twisted shielded cable or shielded cable. The shielding layer of the cable shall be single-ended grounded on the CNC side. The signal line shall be as short as possible. 5. In order to reduce the mutual interference between CNC signal cables and strong current cables, the following principles should be followed during wiring. Thanks for watching.